Hello students, in class 11th, today I will tell you about the transverse Doppler effect. You all watch this video completely and whatever is important you note in your notebook so that you could see at any time. Also you can study by watching the video. So you all subscribe, share and like the video. So I am taking the transverse Doppler effect. I told you when I started the Doppler effect, that Doppler effect is of two kinds. One is the longitudinal and second the transverse. In longitudinal, all the this sound source and the observer moves in a straight line, parallel or anti-parallel to each other, or they are moved in the circular path. But in case of transverse Doppler effect, the observer is in the direction perpendicular to the motion of the sound source, or the sound source is constant and the observer is moving perpendicular to the direction of the motion of the sound source. So most prominent is that the sound source is moving and observer is at right angle to the direction of motion of the sound source. Then this is called the transverse Doppler effect. Transverse Doppler effect. When sound source moves perpendicular to the direction of observer. It is called transverse Doppler effect. So now let's Vs equal to the speed of sound source. This is the sound source. This is our sound source S. It is moving. This is suppose the point T we take here. This is the observer O. You can see that this is 90 dBm and observer is constant. So V0 is equal to 0. This is suppose point A and this is suppose point B. Now this distance AT and TB both are the equal and this is now here, then we can join to this line, and also we can join to this line. What? This is now speed Vs. Now we can have the components of this Vs. One component along this OA. This is now Vs cos theta. Vs cos theta. Where this angle is theta. Then what? Let observer is constant. It means V naught is equal to 0. When the observer moves towards the point T, where this is at the right angle to this observer, so at the point A, at point A, the component Vs cos theta is towards the observer. It means that the frequency will increase when the sound source goes from this A to T. The apparent frequency at point A, this n dash equal to V upon V minus Vs cos theta into n. This is so much. And you can see that at the point T, at point T, theta equal to 90 degree, or cos theta equal to 0. It means that this factor will be 0. So n dash equal to n. So n dash equal to n. It means no Doppler effect. No Doppler effect. And when it crosses the T and reaches at the point A, then again we are having the speed Vs, and this will be just opposite to this one. So this is the maximum frequency. The apparent frequency increases up to point T. At point B, the apparent frequency n dash equal to V upon V plus Vs cos theta into n. And you can see from here that as theta increases, this frequency will decrease. So the sound source is going away from the observer, and ns will be less than n. So apparent frequency decreases. After crossing point T, the apparent frequency decreases. And you can see that as this value increases, then this at theta equal to 180 degrees, this will be a minus, so this is the V minus Vs, this means it is coming opposite. So this is what the transverse Doppler effect. If suppose the observer is also moving, let observer is also moving, then V naught is not equal to 0. So what happens that we are having to this one, this is now O, V naught, this is the sound source moving like this. This is now, then this is now point A, and suppose this is now point B, then again so what will we have? The observer is moving away from the source. And this is the angle 90 degree. This is now your Vs. So this is your Vs cos theta. Vs cos theta. At point A, n dash equal to V minus V naught upon V minus Vs cos theta into n, and at point B, this n dash equal to V minus V naught upon V plus Vs cos theta into n. This is when this is going away from this sound source, and if suppose this is coming towards the sound source. And second case we can take when suppose this is the source, this is the observer O, this is moving with this speed V naught, and here we will have this A, and this is also, this is now A, this is moving sound source, now this is now like this. Then इसको हटा ही देते हैं। I think the second part may not be there. We are having only the sound source when it is moving perpendicular to the direction of this observer. So this is all about the transverse Doppler effect. You all like, share and subscribe this video. Thank you very much.